Okay, we're going to look at a quadratic form today. And we can say that a quadratic expression has form ax squared plus bx plus c. And notice that if this is arranged in proper order, that if we take the middle variable and square it, we get the first variable. And that would be something for quadratic form to look for. So for example, if we have x to the 4 plus 2x squared plus 1. Right? If I take the middle variable x squared and square it, we get x to the 4, which is the first variable. So quadratic form. Let's look at another example. X to the 6 plus 3x. This would have to be a cube plus a 2. Because I take that x cubed and square it, we get x to the 6. So the exponents have to be offset by 2, a factor of 2 from each other. Here's another one. X to the negative 4 plus 5, x to the negative 2 plus 6. If I take x to the negative 2 and square it, we get x to the negative 4. And they don't have to be integer exponents. They can be fractional exponents and still have quadratic form. So if we have, say, x to the negative 2/3 plus 4x to the negative 1/3 plus 3. If we take that x to the negative 1/3 and square it, we use the property of exponents where we multiply them together. We get x to the negative 2/3, which is the first variable. So looking for quadratic form, that's what we want to look for, that kind of relationship. So let's look at an example. The question says to solve x to the negative 2/3 plus 4x to the negative 1/3 plus 3 is equal to 0. And so here, if we introduce a variable to substitution, if we let u equal x to the negative 1/3, then u squared is x to the negative 2/3. And so that equation becomes u squared plus 4 times u plus 3 is equal to 0. And now from here, we can use our standard techniques to solve a quadratic. We can factor, right? What are the factors of 3 that add together to give 4? A 3 and a 1. So we know we're going to be able to factor this as u plus 3 and u plus 1 equal to 0. And now setting each factor to 0, we would have u plus 3 is equal to 0, or u plus 1 is equal to 0. And solving each of those equations give us two solutions to the quadratic form. The u equal negative 3, or u is equal to negative 1. And now we want to go back to the original variable by looking at what we substituted, what u is representing. And u is representing x to the negative 1/3. So the first equation becomes x to the negative 1/3 is equal to negative 3. And the second equation becomes x to the negative 1/3 is equal to negative 1. And now we want to solve each of these mini equations, remembering that a negative exponent just means that we have it in the denominator. So this would be 1 over x to the 1/3 is equal to negative 3. And as long as x does not equal 0, we can multiply both sides by common denominator. And we can rewrite this equation as x to the 1/3 is equal to negative 1/3. So I'm going to reciprocate both sides. And then the second equation becomes x to the 1/3 is equal to negative 1 when we reciprocate both sides. And now how do you get rid of the cubed root? You cube both sides because, all right, this is the cubed root of x is equal to 1/3. So cubing both sides, we would have x is equal to negative 1/3 cubed, which is negative 1 over 27. There's our first solution. And then the second one, cubing both sides, we would have x is equal to negative 1 cubed. Negative 1 cubed is negative 1. So those are the two solutions to this quadratic equation, quadratic form equation. We can see equations that might look a little different. We remember parentheses are a grouping tool, right? Parentheses are keeping terms together. So maybe we have an equation like this. 2x minus 3 squared plus 5 times 2x minus 3 minus 6 is equal to 0. And so if I introduce a new substitution, we would have u is equal to 2x minus 3, because that's the thing that's being repeated, right? And being in quadratic form. So then the equation has form u squared plus 5 times u minus 6 is equal to 0. And again, we can use our factoring technique. What are the factors of negative 6 that combine together to give 5? Would be a positive 6 and a negative 1. So this will factor as u plus 6 times u minus 1. And setting each factor to 0, we would have u plus 6 is equal to 0, or u minus 1 is equal to 0. And now solving each of those, we have two solutions to the quadratic form. U is equal to negative 6, or u is equal to positive 1. And now go back to the original variable, remembering that we let u equal to 2x minus 3. So the first equation becomes 2x minus 3 is equal to negative 6. And the second equation becomes 2x minus 3 is equal to 1. And now solving each of those, add 3 to both sides. We have 2x is equal to negative 6 plus 3 is negative 3. Or add 3 over here to the second one. 2x is equal to 1 plus 3, which is 4. And now the last step, divide both sides by 2. So the first equation gives us a solution that x is equal to negative 3 halves. And the second equation gives us a solution that x is equal to 2. And these are the two solutions to that quadratic equation. Right. Of course, something like this one, if you wanted to, you could have multiplied everything out and collected like terms and then solve the resulting quadratic equation. But that is only going to work for this type of equation when you have this kind of substitution. Anyway, I hope that helps.